Hello and welcome to 30 Mechanical Minutes, virtual content for real-time professionals. My name is Doug Picklick. I'm the editor of HPAC magazine, and today we're going to be talking about heat pump water heaters for homes. I'm joined today by longtime HPAC magazine contributing writer and plumbing specialist, Steve Goldie. Hi, Steve.
Hey, Doug.
Nice to see you.
You too.
Okay, so before we begin, I wanted to thank our sponsor for today, and that is Bradford White Water Heaters, manufacturers of residential and commercial water heating solutions, including its Aerotherm series of heat pump water heaters. Bradford White, thank you very much for your support. And let's go. Steve, this is while I was diving back through some of the HPAC magazine archives, I came across an article that you wrote. It was back in March of 2019. And this was the title, Heat Pump Water Heater Potential Remains Unrealized. And you wrote—
I think that.
Oh, go ahead.
Yeah, I think that might have been the second article I wrote about heat pump water heaters, actually.
No,
I had an earlier.
You mentioned in this article that it was a decade prior to that, almost, that you had written about heat pump water heaters. So they've been on the market a fairly long time, and you've known about them for some time. So I was thinking, as we get started here, maybe you could just give us a little bit of a background on just exactly what a heat pump water heater is and how it works.
Sure. Well, so heat pump water heater. Well, when I do training, is I like to, when we talk about heat pumps, whether it be heat pump water heaters or heat pumps for heating your house or cooling your home, I always ask people, does anyone have a heat pump in their house? And they often get blank stares and like people, no. And I said, you sure? And I said, and everyone kind of looks at me blankly. I said, how do you keep your beer cold? I said, well, your refrigerator is a heat pump. And that kind of helps people, okay. So basically a heat pump is using a refrigeration cycle to move heat. And, we can't, heat is constant in the universe. So when you're heating or cooling something, we're moving heat. So a refrigerator, you use a refrigeration cycle to pump, as it were, or move heat out of a box to make the inside of the box cold. And with a heat pump water heater, we're doing the same thing in reverse. We're pumping or moving heat. We're taking heat, extracting it from the ambient air, either of the room or from outside. We're taking that heat and moving it, as it were, pumping it and transferring it into the water inside the tank. So that's the best illustration I can give to people about what a heat pump water heater is, or what a heat pump is.
Okay, and there's a lot of them on the market, right? I mean, I know back more than a decade ago when there were maybe just a few.
Yeah, there was a handful back, certainly, 10, 15 years ago when I first wrote about it, there was only, a handful. Now there's countless, options on the market. As with all things, the move away from fossil fuels is driving this. So pretty much every major manufacturer has a heat pump water heater now.
Okay, there's a selection of a few on the market. These all have that form factor where the heat pump's on the top and the tank on the bottom.
Yeah,
okay.
Unlike most refrigerators where you got your compressor down below, and with the heat pump water heaters, we have them up top typically, but that's makes more sense because you got a tank full of water, which is much heavy. You don't want to put that on top. Right.
Okay, now aside from the mechanics, how the heat pump puts heat into the tank, into the water, I know more people are familiar with both like gas heated and electric tank water heaters. And all these water heaters are compared. I know when you go and buy them, that EnerGuide logo, it has a UEF rating on it. And I'm hoping you can explain a bit of that for us, the UEF rating, and then what that means or heat
Right.
pump.
So there's lots of different types of energy rating systems, and UEF stands for Uniform Energy Factor, UEF. And again, who knows what that means, but it's just another way of looking at the energy you're putting in and calculating how much of that energy is going into heating the water in this case, or in a furnace or a boiler, or boiler heating water, in a furnace heating air. How much of the energy that I'm paying for is actually heating and how much is lost. And in a gas-fired hot water tank, you're burning gas, which has a caloric content, a certain amount of BTUs per cubic foot. How many of that BTUs are actually transforming hot water into hot water? How much of that heat's going up the chimney or out the sidewall chimney? And then you get a efficiency factor from that. With an electric hot water heater, I've always told people electric's virtually 100% efficient in a sense, because all of that resistance element, all the electricity, the kilowatts going through your resistance element, pretty much all of that's going into making heat going into your water. Very, very few losses in that sense. With the UEF factor, you see you're getting numbers of 2.3 to 4. So that means you're more than 100% efficient. So how can that be? Well, with a heat pump water heater, again, we're moving heat, we're pumping heat. So the electricity is used to drive a compressor and in your refrigeration cycle, and maybe some fans, but we're actually stealing heat from the ambient air. So we're moving heat, and we're not just making the heat with that natural gas or the element, we're moving it. We're taking it from the ambient air and putting it in the water. So the energy factor, how much energy it's costing to run that compressor, compared to how much actual kilowatt heat energy I'm getting. And that's where they calculate that number. So we are getting a lot more than 100% efficiency, as it were, because we're getting more than 100% of kilowatts in heat energy, because we're actually moving heat and stealing it, if that makes sense.
And they talk about this first hour rating, that amount of hot water the unit can provide in 1 hour of operation with a full tank of heated water. Goes into this calculation some.
So, first hour rating basically means, if you've got a stored hot water heater type system where you've got X amount of gallons, 40, 50, 60 gallons of water stored, and then you've got a recovery number, whether you're being with electric or with gas fired or with heat pump, the recovery numbers tells you how much hot water I can make in an hour, and that first hour rating is combining your recovery with your dump load, or how much I've got standing in the tank already heated.
Right.
So that's what a first hour rating is all about. How much in that first hour, when I turn on the tap, how much water am I going to get in that first hour? And so that's a combination of your recovery, how fast you're making it, and the stored energy in the water in the tank.
Okay. So we're talking about heat pumps, and I know contractors out there and plumbers, the people who are used to, I think, installing water heaters, perhaps, maybe have a few concerns when it comes to this new technology, because it's somewhat foreign still. They're relatively new, although, like you said, they've been around for well over a decade. But there may have some concerns with regards to when it comes to installations or maintenance, perhaps, of these things. So we got together a little list of rapid fire questions for you here. So let's see.
Okay.
Let's have you answer some of these questions. So are they difficult to install? There's a refrigeration cycle involved. So do I need a refrigeration ticket to install these things?
Well, do you need a refrigeration ticket to plug in your refrigerator in your house when you buy a new fridge?
No.
So the refrigeration cycle is all self-contained. It's all, the compressor, the refrigerant, the coil, that's all self-contained and built and pre-built in the factory. Refrigerant's already charged in the factory. So that's just like your refrigerator that you would go and buy it, whatever store you're buying at, you bring it home, you plug it in, and it runs. A heat pump water heater is the same thing. So as a plumber, you're gonna uncrate this thing, put it in place, pipe it up as you would a conventional hot water heater, and you're going to plug it in and it's going to run. So there's no refrigeration license needed, and there's no refrigeration expertise needed to install this for the plumber. Nothing to be afraid of.
And when it comes to installing, I guess, unlike a gas unit, there's no venting.
No venting, as you know, there's no gas venting, there's no combustion cycle. So, you know, you need to make sure you've got air. You know, you're taking ambient air from the room, or some of the units have, you know, you've got ducting. So you can duct and take your air from outside and exhaust it to the outside, because again, we're doing a refrigeration cycle. So if we're stealing heat from the air, that means we're cooling the air. So the incoming air, we're going to steal some of that heat. So the exhaust air is going to be cooling down. Now, there's no intake and exhaust if you're just putting it in the room without piping it, but you can actually pipe them to the outside air, which would be something that you could do, especially if you're in the south and you got warmer outdoor air all year long. You could take that, the warmer the air, the more efficient the unit's going to be. So you could take the warmer outdoor air and then dump the chilled air into your space, and you're actually going to get some benefit of some additional cooling as well.
Yeah, that's the thing. They need that airflow, right? And like you said, they're stealing heat from your space heating at times. So in the winter months, they're stealing some of your heat, but in the summer, they're providing some cooling and dehumidifying. Okay, what about the water temperature? How hot do these things get?
Well, you can get as hot as a conventional water heater for the most part. And again, many of them are hybrids. So they will have a backup, or not necessarily backup, but they would also have a conventional immersion electrical element. And most of them can work with either or both, depending on, the user can choose to operate with either or both.
Okay, yeah, that's an idea of the hybrid water heater.
Yeah, most of them are, have both options.
Okay.
I say most of the residential versions, which is what we're talking about here.
Right. Yes. Yeah. For the home here. Are they noisy? I think pumps can be noisy at startup.
It's noise is one of those questions that people always ask about, and I'm always careful when people ask, is it noisy? Is it, I never say it's silent. If it's got a moving part, your electric hot water heater, your conventional electric is pretty much silent, because there's no moving parts. It's just an immersion element. So compared to a conventional electric hot water tank, they're going to be noisier. Noise is a relative term. Where you're putting it, and who's beside it is going to have a lot to say about how noisy it is. Do they make noise? Yes. There's a compressor. Just like, again, go back to the refrigerator illustration. Is your fridge noisy? An old clunky fridge might be. Newer ones, they're not silent. You hear them when that compressor kicks on, but how noisy are they? Heat pump water heater is going to be similar, a little bit noisier. There's also a fan, but so there's a fan and a compressor. So you're going to have some mechanical noise, but they're not particularly noisy. And again, if you're going into a mechanical room, that's not going to be a huge concern.
Okay.
That being said, I'm going to get a customer. You're going to get a customer if you tell them, oh, it's quiet, you're never going to hear it. If you say you're never going to hear it, and your customer says, well, in the middle of the night, I hear that come on, and if I really listen, you're going to get that customer says, you told me I'd never hear it, and I hear it. So don't ever tell the customer, they won't hear it. They'll hear it.
Okay, fair enough. So it's a water heater. People these days are talking about setting up hot water recirc lines. I can do the same thing with one of these.
Absolutely. You've got a tank of water. So as long as you got a tank full of hot water, you can do recirc.
Okay. What about maintenance?
Well, there's more moving parts than, again, to go back to a conventional electric hot water heater, there's more moving parts. Your old atmospheric gas water heaters, your old, and your electric hot water heater, there's not much to do in the way of service of those. We should change anode rods so they can last longer without rusting. Do people do that? Some people do, most people don't, but there's a maintenance item that should be done regardless. But there's moving parts. You've got a compressor, you've got fans, so you've got more moving parts. More moving parts means more potential for breakdown, more potential for service. So yes, there's going to be potentially a bit more service or maintenance on these.
Okay. And then one of the barriers I think that people face is this idea of the expensive upfront cost, right? How much more
Yes.
expensive are these things than my standard electric or gas, whether it's condensing? Oh, I guess I think they need to be condensing these days, right?
Well, not residentially, but a residential condensing gas water heater is going to be as expensive or more expensive up front. Your conventional gas water heater is going to be a little bit less, but not a whole lot less nowadays. Your conventional immersion element electric, that's the cheapest hot water heater out in the marketplace still. So this is going to be, more than double that up front. But again, your savings, you're going to be saving, 200 or 300% of, you're going to be running it 2 to 3 times more economically than those. Now, residentially, how much do we spend to heat hot water? Average family going to be, probably spending anywhere from $650 to $1,000 annually, depending on where you are in the country, to heat hot water. So if I'm cutting that by, 2/3, I'm still going to save, potentially $600 a year, maybe $400 a year. It's not insignificant.
Yeah.
So a payback is still, is the payback is in the realm of, this still makes sense in my mind. You're
Right.
looking at a maybe 3 to 5 year payback in that case. So it's definitely worthwhile.
Okay, and then of course, heat pumps in all styles are hot these days, and the government is providing all sorts of incentives.
Yep.
These units, right?
One of the few places where the government still wants to throw money at us. Yep.
Yes. So because this is a national program, our webinar is reaching across the country. In terms of federal programs, there is the Greener Homes Grant, of course. This slide kind of outlines, kind of some of those basics for eligibility for people to take part. When it comes to the heat pump water heaters, there's a list of the eligible products. I perused that list just earlier today. There's over 300 different models from about 20 brands.
Wow.
And these are
tanks. There you go.
These are systems from 36 up to 82. I think I even saw 83 gallon, but say 40 to 80 gallon solutions. And these lists are updated quarterly. This one had been updated as of June 1st. So
okay, so
a lot of units to choose from.
Yeah, a lot more units than there were like 10 years ago, like I say.
Yeah, for sure. And then again, here's some of the other criteria. It has to be installed by a licensed and trained professional, and the grant amount is $1,000. So I think that's a good chunk off of that initial investment.
Well, that makes that payment, payback period come down a great deal right there. And and I think that the last couple of years, when I wrote that article in 2019, I think the title was, still unrealized potential, because we weren't selling a whole lot of them. In the last couple of years, that's turning around, and we're seeing a lot more interest and a lot more actual, that interest is translating into actual sales now. So we're starting to see these things move. So I'm sure that's in large part due to, incentives that are out there and just a heightened awareness and desire for this type of product.
Very much so. Okay, we are almost less than 10 minutes to 12, and I see we got quite a few questions here. So I'm going to just hop right into this and see if there's some questions. Okay, David asks, if we take the heat out of the room in the house, are we then adding to the heating space load?
So yes, if you you will be taking heat out of the heat in the ambient air in the room. So in the wintertime, when you're paying money to heat that house, you are going to be cooling that air that you've just paid money to heat. So there's going to be a bit of a trade-off there. It's not significant, but it is there. The way around that again is you can duct most of these units. You can duct to and from the outdoor air. Now you don't want to be bringing the outdoor air in the wintertime. You could duct it to the outside, so you're blowing the cooler air out, but you're still stealing the heat from the ambient air. So yes, you're going to lose a bit of efficiency there.
Okay, someone's asking, is the UEF equal to that COP number, coefficient of?
Yes, very similar number. Now
Similar,
how they
but
calculate? Yeah, yes.
yeah, similar, but I think yeah,
I don't think I can't say that they're both calculated exactly the same way, but it's basically the same thing.
okay. Mark asks, what's the lowest ambient temperature the heat pump water heater requires to operate?
Well, the lowest I've seen on residential hot water heaters is about 40 degrees Fahrenheit. Now you're never going to be there inside of a house. Now in the States, in southern, more southern areas, a lot of people put up their hot water heaters in the garage. So that's not really a concern up here in Canada. But if you're installing it in a garage in a southern climate, somewhere where your temperature could actually get below that, you've got two issues. If it starts getting below 40, you got a concern about freezing up. But they're not going to work as efficiently or at all down there. That it's not like the low ambient hot heat pump room heaters that are specifically designed to work in -degree temperature in Canada. These are not designed for that. They're meant to be in a warmer ambient space. So I think around 40 degrees Fahrenheit is about as low as I've seen most of the residential units operate at.
Very good. Someone's asked, Paul is saying, under what circumstances do you need an expansion tank?
It would be no different than any other, hot water heater. So expansion in a hot water heater, water heater, if no water is running, is in theory still a closed vessel. Now, if you don't have a check valve on the incoming cold water, as your water heats up and expands, it basically just pushes water out back into the city line. As soon as you put a check valve on that to prevent that expansion from going out into the city line, you need an expansion tank to accommodate that expanding heated water. That would go for a heat pump water heater, a gas-fired hot water heater, or a conventional electric hot water heater. No change.
Okay. Scott asks, don't heat pump water heaters need to have a stratified storage tank for efficiency? If so, what are your concerns for Legionella?
Well, no. So you still are going to be heating the hot water heat up in Canada to a minimum of 140 degrees. So it's like any other storage hot water heater. You're going to be storing your water at 140 or better to combat the Legionella.
Okay.
And you're going to get stratification in any hot water heater, whether it's gas fired, electric immersion heater, you're going to get stratification. But these are no different.
Syed asks if it can work at -10 degrees Celsius. I think the answer to that's no, but
no.
These units are placed indoors, like you're saying. I mean, so you're not going to get below zero. You hope. Some
of the commercial units, we're not really talking about those, but some of the commercial units are much like your conventional heat pumps where you've got an indoor and outdoor unit. They may work. I can't speak to that, because I haven't really looked into it, but it's possible. We're dealing with the residential versions, which are going to go in the room and they're self-contained. So they're not designed to work in below freezing temperatures.
Yeah. That's right. And in fact, this we kind of addressed this, but Abdul asks about the focus. He recognizes that the focus of this webinar is residential. However, he believes that this is applicable to the commercial buildings of larger size. If so, are those modular or are bigger sizes available? So yeah, you know what? I'm going to take this one. And Abdul, we are planning to have a 30 mechanical minutes webinar on just commercial heat pump water heaters, because that is a whole different category. So yeah, we can't really, we're not going to address that one today. Stay tuned. All right. Craig asked, what is the decibel level of the sound? I think, Steve, you said it's like a fridge kicking in. Is that about right?
Often, I think I looked at a chart the other day that said I think it was about 54 was the loudest that I saw. And again, I'm going from memory here, but I think about 54 decibels was the loudest. I'm not an expert on decibels. I don't know what that compares to, but it was not overly now. And that's if you're standing right beside it when it's running on the exhaust side.
Okay. Craig says here, power vents are 50 plus decibels.
So it'd be in the same range.
Yeah. Paul here is oh, this is kind of taking us off a little bit, but I'm interested in using a heat pump to heat a buffer tank and use a heat exchanger to heat the domestic hot water. Can you talk about such systems? That's a whole other kettle of fish, yeah?
Yeah, that's that. Yeah, we could talk about that, but we don't think we have time here.
Yeah, but that's, I'll tell you what, there's a lot of, John Siegenthaler has written a lot about that in past issues of HVAC magazine, in terms of using a heat pump for an air to water heat pump as a complete solution for your heating and domestic hot water use. So yes, that can certainly be done. I would suggest reading up on that. We've got lots of content on that online. How cold will this make a small mechanical room if exhaust not piped to exterior of building?
Well, first of all, the mechanic room itself should have ventilation. So you're going to have, airflow through that room. So it's shouldn't be sealed that it's going to cool down. And it's not a significant enough cooling that you couldn't use it as a cooling appliance. You're not going to cool your room with this.
Right. Okay. So you've kind of addressed some of these other questions. Again, we're using indoor heat from the indoor space, but you need space around the heat pump so it has airflow through it. Right.
Right. If you put this in a room that didn't have airflow and it was small enough, I'm sure you could chill that room much like you're going to chill the inside of your refrigerator. You don't want to do that. That's a problem, obviously, because as you're chilling that air, that same air is going to make your heat pump water heater less efficient because the ambient air is cooling. So you want airflow. Is it going to cool the room, the air in your house? Noticeably, no.
Okay. So here's someone asking what type of environmental friendly refrigerant is used in these heat pumps. I don't know the answer to that one right now. I don't know, Steve.
No, I don't know. It's not something I looked at, but whatever it is, it's going to have to be meet whatever current standards there are in Canada. And I know in other parts of the world they're using all sorts of things, and CO2 is being used as a refrigerant. I'm seeing, and so what they're using in these, I'm sure it varies between manufacturer, but they would all have to have current approvals.
Okay, here's one. Someone mentioned this one, and we had talked about this, Steve. Actually, Sandon, the Sand CO2 has a separate outdoor unit, as with the typical heat pump.
Right.
That was one unit that isn't that standard tank with the heat pump on.
That's got the separate, yes.
Yeah. So that I just wanted to, bring that up because that was an interesting design. And the person here is suggesting that might be rated for as low as -20 because the compressor is actually outside. So that is something.
And again, I think they're mostly commercial units.
But people can look into that. It is listed on the Greener Home Grant list of heat pumps. So I would say take a look for that. Okay. If there's any questions that happened in the chat that we didn't see, I'll have to apologize for that, but hopefully we can get back to you. after.
So they have residential units too. Okay, sorry.
Yeah, we'll get those questions to
Nope.
you. So that's it for today. So before we leave, again, I want to thank our sponsor for today, which was Bradford White Water Heaters. If you're looking for information, you can find that at bradfordwhite.com. And Steve, again, thank you for participating.
Thank you.
Really, it's always a pleasure to speak with you and learn a little bit more about what's going on. So,
Well, it's always a learning experience for me too. So there you go.
all right.
Thanks, Doug.
And of course, thank you to everyone who joined us today. Again, this recording of this session will be on our website in a few days from now. That's hpacmag.com. And you can always find past episodes of 30 Mechanical Minutes on our website under the Tech Pulse section of our website. And also we post them on our YouTube channel. You can find that by searching the at hpacmag, at hpacmag. So there you'll find it there. All right, so until next time, thank you everyone for joining us. Thanks again, Steve. Thank you, Bradford.
Thanks, Doug.
Bye for now.
Bye.